5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
IBM has worked on space-related projects since before I was even born.
It's one small step for man.
A team of 4,000 IBM engineers helped create the Saturn V rocket that took Neil Armstrong to the moon.
One giant leap for mankind.
And when I think of NASA, I tend to picture the moon landing, or the team of people back in Houston guiding the Apollo mission, or the Hubble telescope, or astronauts aboard the International Space Station. What I didn't think about, until now, are NASA's geographers. I'm Malcolm Gladwell, host of the podcast Smart Talks with IBM. I'm here in Washington, D.C. at IBM's offices asking a fundamental question. How can artificial intelligence help us unlock new ways to understand and track our planet? On today's episode, we're exploring how NASA and IBM are building geospatial AI models designed to make sense of decades of satellite data. AI models that can transform raw information into insight, helping us better understand our planet and prepare for the challenges ahead. I first spoke with Kevin Murphy, Chief Science Data Officer at NASA's Science Mission Directorate. Kevin has been at the agency since graduate school. His background is in geography. So this is the first thing I wanted to get into, which is that when people think about NASA, they think it's all going to the moon.
Sure. So
but you're not involved with going places.
No. Well, yes and no.
Yes.
Right. So in order to go places, you need to map things. But I think that there's an assumption that NASA is all about rockets and astronauts, and certainly that's a really large part and important part of NASA. But we also have a lot of scientific missions where we take measurements of the sun, of the Earth, of the moon, of Mars, of distant planets, in other galaxies, and we take that information and really advance science.
NASA builds rockets, spacecraft, and the satellites that orbit the Earth. But it also generates, collects, and shares vast amounts of scientific data from dozens of instruments. And the application of AI has unlocked some unexpected patterns.
So one of the really kind of cool but unexpected observations that we had is that we launched a pair of satellites in the early 2000s called GRACE. And these satellites...
Called GRACE?
GRACE, yeah. And these satellites orbit the Earth, and they have... they can measure very precisely the distance that they're away from each other as they orbit the Earth. As you go into gravity wells, you can actually see a satellite accelerate and the other one accelerate after it, right? Mm-hmm. And using that information, we were trying to map kind of the gravity fields of Earth. And what they found is that they can actually map below kind of the mass of Earth to where water storage is, for instance, so aquifers, right? So you can monitor through gravity how much water is being depleted or added to an aquifer, or the density of glaciers.
So, just to back up for a moment, the presence and density of water deposits below the Earth's surface have an effect on gravitational fields that are being measured in space.
Correct.
This brought me to my next question. What are all the possibilities if NASA's mountain of data could be organized, analyzed, understood by artificial intelligence?
Everything started with a question, right? As we advance AI, we have new tools to understand the surroundings, understand the world, understand the language, and understand our planet. And the question that we were asking ourselves was like, all these new advances that we see in language, it was a post-GPT moment. Could we apply the same idea and the same architecture and technology to data about our planet?
The idea was to build foundation models to help understand a kind of big picture master plan version of all that information. But would it work? Would it be worth the time and trouble? It was able to extrapolate on the basis of 1% of the data what the entire picture looked like.
Yes.
Wow.
Because pre-learned everything, right?
Yeah. It pre-learned the kind of principles of...
Exactly.
Yeah. Oh, wow.
Yeah.
That is incredibly impressive.
That's very, very impressive.
Wait, so how did, at that moment, when you realized you could do that, I'm just curious about your emotional. I mean, did you jump up and down? What did you do?
We were like, we were having such a nice, right? It's like, wow. Like, and it was a very emotional meeting because, having this person say, now I'm convinced, right? It was kind of quite a special moment. These moments make your life as a researcher.
In 2023, IBM and NASA launched a foundation model trained on NASA's harmonized Landsat Sentinel-2 satellite data across the continental United States. They named the model Prithvi, the Sanskrit word for Earth. IBM and NASA launched Prithvi for weather and climate in 2024. And while IBM and NASA scientists could use Prithvi to run interesting experiments, they were even more excited about how Prithvi could help people in the real world. From orbiting satellites to AI-powered decisions to unlocking hidden patterns in Earth's data, IBM and NASA are using the Prithvi family of models to help us see our planet more clearly and prepare for what lies ahead. To hear the stories of how Prithvi has already started making a difference in Kenya and the UK, listen to the full episode of Smart Talks with IBM.